Hi there. Let's start with the first topic in F3, that is System Development Life Cycle, or also called as SDLC in short. So what are we going to learn in this? Sir, understand when a software needs to be developed. See, I work for a software company. I am the, as on the date of recording this lecture, I am the product manager for ERP group. So product manager, the name itself is clear. I manage the entire product of ERP, accounts payable, accounts receivable, then your billing software, then your general ledger, bank reconciliations, compliance module, payroll, HRMS, CRM, and inventory, budgeting and forecasting. So all these modules together is formed as an ERP. So I head the ERP product. So I basically do a market research, then I find out, okay, these are the features and functionalities that are expected out of each individual system. So these features should be there, these features should not be there, or this is the process flow. I'll define the process flow. I'll give the specifications for the development team so that they can work on developing the system. So I tell them, I define what is the system and they design the system based on my definition. Okay, so I'm actively hands-on involved with the software development process as such, so I can give you better inputs on this topic. So now there are different stages involved in the development of softwares. Okay, so what are these stages, and so what are these stages? We are going to discuss this in this particular topic. So now there are 5 stages involved in the development of a software. What are the 5 stages involved? So the first stage, if you can see the screen here, so the first stage is the system analysis phase. So system analysis means what? So first we are going to understand what is the need for the system, what is the current system, what are the deficiencies in the current system, why do we need a new system, or why do we need a development or a new version to it. Okay, so for example, right now you are using WhatsApp, for example. So WhatsApp has some restrictions. So if you are logging into a new device, so your chats are gone unless you back it up to the Google Drive first and then again restore it back from the Google Drive, or else you do some kind of transfers of WhatsApp or something like that, fine. Otherwise your data is not actually stored in a cloud and that cannot be accessed anytime, anywhere on a new device. But on the other hand, if you see Telegram, basically you just log in with your mobile number OTP or your mobile number OTP plus a 2-factor password, and then bingo, you got your chats. It's as simple as that. You can open your Telegram on any mobile, any desktop, or a web, or a tab, or any applications or any platform for that matter. So Telegram has this additional advantage. Similarly on WhatsApp, if you are in a group, for example, if you created a group, there has been 10 days of conversation in that group, and now you are adding another person to that group. They will not be able to see what happened in the last 10 days. But on the Telegram, you can just turn on a setting and say that chat history visible. Automatically, anybody who is joining the conversation will be able to see the entire chat history in that chat. So there are some advantages to Telegram. So WhatsApp might want to start a new version of it, or they might want to release an enhanced version of it. So this is called as system analysis. What are the features that are currently present in the system, and what kind of enhancements are being expected by the market, okay, or the users, or maybe the product manager themselves is triggering and saying that, okay, we need these features and functionalities in the next version of the software. So that is system analysis. So at this phase, there is also something else that happens. There is also feasibility study. So what is feasibility study? Feasibility study means basically, sir, I want to have a feature which will, I just scan a particular invoice, automatically the system will record the sales transaction, record the bills receivable, send a notice to the customer, send a copy of the invoice to the customer, and automatically update my aging schedule of receivables. Then prepare the P&L balance sheet. After 15 days, send a notification to the customer saying that your bill is due, and also give me analysis of my entire dashboard analysis of receivables, and file my GST returns, automatically send this to GSTR1 or something like that. See, this is all an expectation, fine. You are looking for new feature, but the problem is it possible or not? If possible, what are the blockers that are there. Like for example, you want to automatically update your GST returns. That means you have to get an API from the GST portal and you have to integrate that with your existing software, so that when you scan the invoice, when you scan the barcode on the item, the invoice prepares and updates the GST portal automatically. So that would require a lot of technology, that would require capital, that would require programmer skills, that would require API from the GST portal, that would require a training, the testing of the particular functionality, then that would also require capital. Yes. So time. So all of these are what? Requirements. So feasibility study has to be done. Okay, you are asking for a feature, but is it possible to develop that or not? Do we have the resources to develop that or not? That is also feasibility analysis. That is the feasibility analysis part of system analysis. That is the first step of software development. Second one, conceptual design. Now, what is a conceptual design? See, design means creating something. Now, conceptual design means a bare structure being developed. So, for example, if I just show you here, let me pull up my OneNote quickly. Okay, so if I just take a small alright. So now let's say I want to have a software which will be used to what shall we do? I'm just looking out for some examples. Okay, so I want a UPI integrated accounting software. I'm just randomly pulling up some idea. Okay, so if any one of you is interested and if you can get a venture capitalist, then you can work out on this idea. So let's say we have a lot of UPI apps, right? If you are an Indian, you would understand the UPI. That is a payment platform. So you have the Google Pay, you have Phone Pay, then you have what Bharat Pay. All these kind of pays are there. And if you are not an Indian citizen and if you are unable to understand what I'm talking about, you can link that, or as an alternative example, you can think of Apple Pay or Samsung Pay, etc. Okay, so now I am looking for a software. I want to develop an accounting system that directly connects to these applications, any of these applications. Maybe for example, let's just take Apple Pay or a Samsung Pay for just an example. It could be with any other applications for that matter. And this accounting software, so whenever a payment is made using one of these, let's say for example, we'll take Phone Pay. So whenever I use Phone Pay to make a transaction, I make a payment on Phone Pay, automatically my accounting software should book an expenditure entry for that or a payment entry for that. So debit, whatever account, credit, bank account. Now the problem is, sir, how would the system know which account to debit? Because I might have paid that for for various different reasons. It could be because I purchased a mobile, or it could be because I purchased some groceries, or it could be because I purchased pani puri or whatever it is. So any payment that we made, it might go to office expenses, it might go to office supplies, it might go to an asset, it might be an intangible, or sometimes it could be withdrawal of capital or whatever it is. So we don't know the debit part of the transaction. Now I want an accounting software where there will be a separate table. Pay attention. So there will be a separate table that shows let's say narration, okay, and account number, account name. So I want to use a system where if the system, pay attention, finds the narration. So when you make a payment on Phone Pay or Google Pay, the transaction will have a narration, right? So if the narration of the transaction says food, for example, so the narration, if it includes the word food, automatically it should be posted to GL account number, whatever is the chart of accounts that you are maintaining. It could be named as, for example, food and drinks. Account number is, let's say, 500060, for example. So the chart of accounts, account number is 500060, food and drinks is the name. So this software should automatically look for this table, and suppose this table says if there is a word called travel, it should be 50050 travel expense account. Or if it says computer, it should go to, let's say, 10010 property, plant and equipment ledger. So it now, when the narration is looked upon, so the transaction should look for the narration, find that particular word in this table. Okay, it is found here. So account number is 500060 food and drinks. So automatically debit food and drinks here. Sounds interesting, right? So now here, this is called as, there are multiple technologies which I just explained here without giving you the perfect logic, but I'll explain all of them in step by step. So here in this example, this is called as a conceptual design. See, I'm not actually developing the software here. I'm just saying that, okay, there should be this table. This is a table, maybe called as a lookup table, because it is looking up for those references, and that it should automatically post an accounting entry. It should be integrated with PhonePe, so the transaction would be the triggering event. So this is what, this is an example, or this is the explanation for the functionality of the software. This is called as the conceptual design. Okay, then when the actual design starts, when actually the programmers start designing the interface, designing the login page, designing the narration table, definition table, etc., etc., then that is called as physical design. So in physical design, actual development and actual designing of the system will be done. Conceptual design is more like a planning, high level planning, that okay, these systems should be there, these functions should be there, these tables should be there. So high level planning. Physical design is the more detailed specifications of, okay, there should be this button, if I click this button then this process should run. That is physical design. Then comes implementation and conversion. So what is implementation? So once a software is developed, so once the product is ready, then there should be testing, quality assurance, and after it is passed with the testing phase, then installation on the user systems, and user actually starting to implement that functionality and start using that functionality. And also conversion means existing records also might want to be converted into the new system. Like already in the last 10 days I have made 100 transactions. So those 100 also should be converted into the new system so that those records also will be updated. And last one, once you are done with the software, doesn't mean you leave it like that. There will be operations and maintenance. See, when you download any app on your phone, you go to Play Store, click update all every time. So that means whenever there is a new enhancement, bug fixes or issues identified, etc., etc., they'll update, keep on updating the application. That is called operations and maintenance. Okay, so the 5 stages of software development lifecycle are, I hope, are very clear. So the first phase is where you start analyzing the system and feasibility study. Second stage is a conceptual design, an overall picture of the system, not a detailed explanation, but just the overall summary will be done. Then the third one is your implementation and conversion, physical design, a more detailed design will be done. Then implementation and conversion, actually quality testing, assurance, and then installation on the client side and using it, converting the old data into the new system. Last one is operations and maintenance. So that is your 5 stages of software development life cycle. SDLC, system analysis, conceptual design, physical design, implementation and conversion, operations and maintenance. Okay, so now just for your information, you can read this all later on. Just for your information, usually there are 2 models which can be followed. Again, please read this sentence. These 2 models are not examinable in detail. CMA syllabus does not have this. I'm just giving you for some information purpose. That's all. Just a knowledge purpose, not at all covered in CMA syllabus. So now what are the models used for software development? So there are two models which are mostly used. Majority of the software companies use these two models. What are these two? First one is called as a waterfall model. So waterfall, how it works? So on the top, then it slowly comes down like that. One step, second step, third step, like that. So that is called waterfall model. And then the second one is called as the agile framework. So agile is now very popular, and everybody is talking about it, and everybody wants to use agile in their organizations, blah 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 blah. So I am also certified agile project manager. I don't know why I did that. Randomly I was feeling bored on a weekend and I finished that certification, so that's okay. Now, waterfall model. So what exactly is waterfall model? So here what happens is you have 7 phases for software development. So you can look at those phases, they can match with these 5 steps only. So first one is planning for it and analyzing for it. So these two are covered under the analysis phase of it, system analysis, planning and analyzing. Then design. So design is conceptual design and physical design. Then development, testing and deployment. So these 3 are implementation and conversion. So you test it, develop it and deploy. Sorry, you develop it, test it and deploy it. And then last step is 7th step is maintenance of the software. I don't think there is anything special here. It is basically those 5 steps are covered into 7 steps here. That's all. Nothing much big here. So plan for it, analyze, design, develop, test, deploy and maintain. It's basically the 5 stages of software development restructured a little. Agile is slightly different. So agile is what? So agile is breaking down the entire system into small bits and pieces and working on each part separately. So what happens, let's say in this example, so first integrating with PhonePe. So PhonePe API. So that is the first bit of it. Second bit, so there is an accounting software and that should automatically post accounting entries. That is the one part. Then it should look for narration. It should look for this lookup table for references. So there are bits and pieces. Now what happens is, in agile, we break down the entire work into smaller bits. These are called as sprints. So you can see here, work is divided into short cycles, usually 1 or 2 weeks, called as sprint. Each sprint will focus on completing small, manageable features. So we will not design the entire software at once. So first sprint, okay, login functionality and integration with PhonePe is working. Now our system is able to get a notification whenever there is a transaction on PhonePe. That is first sprint. Second sprint, lookup table and entering the details. So a front-end user interface for adding more records to the lookup table and the logic to look into the lookup table for the narration. Second sprint. Third sprint, posting the accounting entries into the system. So those are 3 different sprints that are done. Okay. Now you are basically dividing your entire work and splitting that into smaller bits and pieces called as sprints. And under agile, what will happen is there will be a loop of it. See the difference here, it is a cycle, it is a circle, whereas here it is a loop. Loop means what? So first you plan for the first part of the work, design, develop, test, deploy, review that first part, launch that first part, again get back to the second part, again second part, design, develop, test, deploy, review, third part, design, develop, test, deploy, review, fourth part, fifth part, sixth part, and last, finally you will be giving it to the user. So usually there is progress that is seen frequently. So you conduct some frequent short meetings called as stand-up meetings and all. All the functional teams will be working together. You collaborate with the customer to understand what are their requirements and where the backlogs are there in the project. And then you always adapt. Agile means what? Agile means movable, easily changeable. So if you're following agile framework, you can easily make some changes. Suppose if customer says that, okay, PhonePe has changed this interface, automatically you can update your software according to that. So that is agile. Okay. So these two are again just for your knowledge. Waterfall is more suitable for well-defined projects, like customer knows exactly what is the requirement and output. So you can follow waterfall. If that is still unsure and we want to figure it out on the way, like we want to figure it out along the way, then we will do agile. Agile is much more comfortable. 90% software companies do agile because clients always come up with new requirements and new functionalities. So agile is more suitable. Anyways, that is not in your syllabus. The syllabus only talks about the 5 steps. system analysis, conceptual design, physical design, implementation and conversion, and operations and maintenance. So just for your information, going back to F3 learning objective statement. So first part, define the SDLC including system analysis, conceptual design, physical design, implementation and conversion, operations and maintenance. This part has been covered in the first lecture F3.1. Okay, so point number A is done from the loss. So in the next lecture, we are going to talk about the automation, process automation, and how it can enhance the performance of the systems and the performance of the organization as a whole. So I'll see you in the next lecture. Until then, keep smiling. Take care. Bye-bye.